All right, guys. I'm Nicolette, and today Brian and I are here with Dhonam Pemba. He is an AI specialist. I understand you also have a background in neural engineering, and you're a former rocket scientist, and you're working on KidX AI. So you're doing a whole bunch of stuff, Dhonam. You're pretty impressive. So thank you for joining us today.
Yeah, thank you for having me here. Yeah, it's a pleasure.
So why don't you kick us off by telling us a little bit about yourself and your background? We've read a little bit about your background. Tell us a little bit about that. It is, like I said, impressive.
Okay, yeah. Let me get. I'll start with college, since that's I think academic wise. But I went to Johns Hopkins, studied biomedical engineering there. I think the main reason was, as when you're doing well in high school, you do well everything, right? Math, biology, physics, and you really don't know what you want to do. So biomedical engineering, I chose that because it was diverse. So I went to Hopkins for that. It's a top ranked school for that. But same thing, I think one of the problems with biomedical engineering is it's too diverse. And you have the problem where you're not specialized. So then I went to grad school. Then I went to California because my family was here. So I went to University of California. And when I was at grad school, I focused more on a specific topic, and that was with the brain. So I was working with, now it's interesting now because Elon Musk started that Neuralink company, and now the brain interface is really popular and everything. But when I was doing it, it was more academic, and funding was very hard. But so we got some funding from the DARPA for the defense, DoD, and it was helping soldiers basically who have like amputees and other injuries to rehabilitate them. So we wanted to make chips for the brain, and basically, microchips for the brain. So that was my PhD work. So I think one of the problems I realized with that is it's a lot of, you don't have Elon Musk and you don't have the billion-dollar budgets, and it's not commercialized. Right. So it was challenging. When we never got to humans, of course, we're just doing animal testing, just recording. But one of the biggest problems with the brain chip is, so anything you put in your body, there's going to be an immune response, right? And it's, so for example, scarring, other things happen. So one issue is now you're reading cells in your brain, right? You're reading them at the microscale, nanoscale. You're trying to read electrical signals in your brain. So imagine you put electrodes in your brain, and now there's scarring around the electrodes. So it's going to reduce the sensitivity. And how do you make it improve better? You got to increase the electricity. So there's a lot of problems with this for long-term implementation. So I think Elon has the best scientists working behind it, but that was the biggest challenge I faced, and I thought it'll never materialize to anything because of this problem. Maybe you can wear a cap and do the outside, but I feel like invasive has this problem with long-term, and I think artificial intelligence might solve that by helping the signals read better. But so that was my PhD work. And so how that transitioned to the rocket science is interesting was, to build these microchips, we had to build these really tiny needles. And at that time, Jet Propulsion Lab from the NASA's one in Pasadena, they had a project where they were trying to build these micro spaceships. It's not really a micro spaceship. It's just small spaceships for altitude changing. And once you're in space, you can send things. Think of like Star Wars, where you have these little things going around. But you're not going to send it from here. But once you payload it out. So the idea behind that was, so if you have a very sharp needle, like a cone, right? So there's a metal called indium, which is low melting point. So around 150 degrees, it's liquid. So think about this: you have a needle, and you just put a lot of metal here, right? So it's like a pool. So now what you do is you put an electric grid here, and like if you charge it, the metal will shoot out like a propeller. So then now it collects right here, all the metals, and this propels, right? Then you can also, after you turn the grid off, it falls back down, so it can recycle. So that was a cool project behind that. So I was working on that, and then that's when actually my first started company. So I'm not actually in the AI background. As biomedical engineering, you do computer programming, you study the brain. You actually study how AI was founded. Like AI was founded based on this thing called Hebbian learning, where the more strength a cell gets, it gets stronger between the connections, and then less. That's why training works, right? You have the same stimulus, and you increase these connections.
Right. Over and over.
Yeah. So we only basically, we study that theoretically, and then we do some programming, but we didn't do like the AI you see right now with deep learning. And so I started my first company when I was doing the JPL project, and that was just a small term project. It wasn't a long term. So that's how I got into kids, and then I've kind of been here for a while now. But so the idea behind that project was, I went that summer, 2007. I went to China on a trip. So it wasn't that summer, but a few years ago, and I've always wondered like why I can't learn language. It's very hard for me. And then some lady was like, "Oh yeah, because you didn't hear it as a kid." And actually, I talked. Then I came back. That made sense. Like there was a professor from MIT called Noam Chomsky. So actually, I went to meet him, and we talked about this too. And basically, what happens is when you're a child, you have the ability to hear every language. But then as you grow up, it's kind of like a tree, right? You start cutting the bushes and you make them specialize. Kind of like AI too, right? AI gets specialized. So the child's brain, if you don't get certain languages, you start losing the ability to hear them and process them. Similar with what's it called? Like Japanese, they have trouble with L and R because they don't have those sounds in their language. So I think that's why we have accents. We have these issues, and it just doesn't apply to language. Even like vision too. Like a child when it's born, it can differentiate faces better than adults. But as we grow up, we start specializing. I think that's why I think when, like us Americans, or if you sometimes you say all Asians look the same, and then Asian people say all the foreign white people look the same. I think it's part of it is because it's actually science, right? Because you've always seen the same type, right? So I think same thing with the AI too, right? Computer vision, it's I think very similar. But anyway, so that's how we want to make this children app. My first company, Kadho, we were trying to expose children to sounds of the world. So when they grow up, they can learn any language. And it was a very good idea. I mean, I think you guys kind of like the idea too. I think, let the baby play games, let them hear French sounds, Spanish sounds, Chinese sounds. Right. But I think one thing, I think the biggest problem I realized was when we went to market, it's a long-term effect. So I think people cannot see if you take your child to a reading class, they learn to read, they learn math. So there was no effect. And then you have people haven't believed this. So we got a lot of downloads, but it was very hard to get sales and conversion. Right. And so
because we're an instant gratification society. And if we're not seeing the results, we don't want to keep paying for it if we don't know,
Right. Well, and it's belief too, right? If you don't, at a certain point, like if you don't see results, some people, they lose that belief factor. Like eventually, oh, this is going to work when they're in their teens now, when they start, or in junior high, when they start learning other languages, this will help. So if they're not, I definitely get it.
Can I ask you a question? It's maybe random, but you said something about the child's brain and you compared it to AI. Yep. So, and then you compared AI to almost like how, like when you're all white people look the same, right? Yeah. And you said like kind of like the AI. So do you think that like the way to improve and make AI more efficient is to really model that child brain and the way the child's brain looks, where it can take everything in, like you're talking about language, where a child can hear all those sounds at that age before it cuts off the branches?
No, I think that is a goal. I don't know if they can do that because I think a lot of people don't even understand how the brain works. And sometimes you don't actually, like how the airplane is not designed after a bird, right? So sometimes you make hacks for, how AI kind of actually learns, and you'll see why I think this is not how actually humans learn. They do a math equation back in calculus and in algebra. You see the slope of a line change, right? So they use that gradient change to make update. So for example, let's say you want to learn someone's face, right? Man versus woman. So just say that at first the AI says woman, but it's wrong, right? Then you know that difference between a man. It's not that simple, but there's a lot of data points. So it uses that slope. There's actually a mathematical equation that does a slope, the gradient, and re-updates the weights in the neural network. So I don't think the brain does that same math equation, right, to update the brain. So I think we've simplified it in that sense that we have data, we have label, and then when we have a result, and when the result's not the same, it's basically updating it. But I believe what you're saying is correct. I think, like children, for example, like when we train AI system, we need to learn everything from, for example, if I want to learn ASR system for speech recognition for French, versus Spanish. You get the new data, you get new text, you label the whole thing over again, right? But a child somehow, maybe he learns the sounds, or maybe he learns some grammar structure, is able to pick up, right? And just second language is easier. You don't have to learn all the sounds from all the beginning. Or children seem to be able to, build on top of each other, right? So AI, I think they're starting to do that. I think the GPT, by OpenAI, they released a model that can, they say human language. So that's what they're trying to do. They just get but it's a little different, right? They get so much data, and then they go for a specific task, and then they train it just for that task. So that's the GPT-3 that OpenAI released. That's a new way, like transfer learning, fine tuning. So I think that's similar to what you were thinking about, like child, right? It has a base, and then you can fine tune.
Right. So let's back up. When we were talking about chips in the brain, right? So what you're working on. So we talked about obviously when you implant something, it's not the connection is not going to be there, right? You with the electrodes, the electricity coming in from the brain. Now you mentioned AI maybe sitting on top of that and being able to analyze that piece from the outside, not so much, being like the chip being injected in the brain. Do you think the AI is going to be a better receptor, like we talked about the algorithms that AI is using? If it could understand what those electrical signals are from the outside, being able to make adjustments to its algorithm when it sees things, like if it sees man or woman, right? And maybe that stimulus of electric.
No, I believe that's correct. I think that might be faster in terms of that. Us solving the biology problem of the body not, covering this electrode up. I think the AI can probably solve the data problem, because, right now the people that they do the cap. When they were doing it, yes, mostly programming, right? They have data, and then they like, for example, like let's say you want to do a system where you put a cap on your head and you want to type. You need to calibrate it for each person's brain signal, right? You do some training and testing. So I think, with enough people's data, like what you mentioned, you have a baseline, right? Then each person, you can just fine tune on that person. And then I feel like the cap can do it. Maybe you need to shave your head, but
I already got that.
Yeah, Brian doesn't have that problem.
I'm good with that. But yeah, I mean, what's interesting about that too is it's almost like what happens is your AI becomes your AI, right? So, once there may be a base AI, but eventually it's gonna be so customized to each person because of the way they think, the way their brain is structured. I mean, there's so many differences in between human beings that it would have to be almost like, Nicolette's AI, Brian's AI, whoever's AI it's attached to.
I agree. I think if it's on you as your person, you just self-correct it every time, right? And keep improving the data and keep labeling. You just label it yourself. Maybe who knows if you have Google Glass type of things, or you just correct yourself.
Right. Yeah.
So, I have a pretty vague and big question, right? Just how powerful is AI?
No, so I think it's still not where people envision. I think simple term is think about what you can do. It's still a lot of computer programming and logic and people behind putting things together. So I think the best way is whatever you can do in a 2-second decision. So think of it as just decision making quick. So you're not gonna, it's not like you can tell AI to plan a trip or do something, but even like when it's driving a car, it's a lot of small AIs put together. So think about what decision you can make. Is it a man? Is it female? Does he have cancer? No cancer? Is it green light, red light? So you're taking these small decisions, because that's what AI is doing, right? It's just getting data and labeling it and differentiating it. Then someone needs to program what happens, right?
Right.
Do this, do that, do that. So it's getting to the point where I think language is getting much more developed, where it's not like this. I guess it can, but it's kind of like mimicking what people speak, right? It just has a lot of text. So I think language is getting more developed in the sense that it can now pass off as humans. It can sound like humans. So I think language-wise, it's pretty advanced. I think in terms of other things like automation, real-world use, it's
are those some of the common misconceptions about AI, that it is more advanced than it really is, because we see it just mimicking humans in some ways?
No, I think because the chatbot and those things can get very good. because now
I don't know, maybe not the ones that I chat with, but I'm sure there are some more advanced ones out there, right?
Well, so that's yes. I think it might be. It's interesting. Like I think maybe it's a culture thing. Like so, Microsoft released well, it was the old generation, but it was the deep learning chatbot, right? And I think they released it on Twitter. Okay. And based on the audience, it started becoming, because of the American and worldwide audience, it became kind of racist and kind of saying bad things, and Microsoft had to take it off. Okay.
Oh, man.
So China released their own version. Microsoft China. They released the girl, and it went well for like 5 years, and it's collected so much data, and now it's its own company, and it's trying to do a lot of stuff. So I think maybe the restrictions on people's public speaking, and
right.
I think it controlled the way that the chatbot developed.
Right.
So that way, yes, I think. But yeah,
it's sort of like a child, though. If you're, you know what I mean. If you're raising a child and you're an asshole, chances are that
I think there's a real correlation here between AI and children. I mean, that's the second time.
No, yeah, I think same thing. Yeah, just developing from the
Well, and so Brian, you brought up misconceptions. Are there any other common misconceptions around the field of artificial intelligence that, you come across often?
Oh, Brian or me?
You.
Oh, me. Oh, sorry. Yeah. No, I think the biggest thing is what you mentioned about, people, the level of AI it is. And I think, people think, I think the other part is the data. People think that it's, invasion of privacy and stealing your data. I mean, it is getting your data, but I think a lot of, you can anonymize a lot of it, right? So I think as long as the person's identity and that stuff is taken out, I think it's not an issue. Yeah.
Now, you also mentioned like Microsoft and AI. Are other companies, like we see so many companies saying they're implementing AI, right? Are there other, capabilities and things that, besides just chatbots that companies, like what are things really companies are using it for?
So I think, most of the company, it is for the customer. The reality is when a company uses it, they need to make money from it, right? It has to translate to something. So a lot of it is for analytics. So like, for example, just say if like call centers or like, auto dealerships or customer service people, they don't use it for the chatbot, but they use it to analyze the calls. Like, so what leads to a sale, what doesn't lead to a sale, this type of thing. I think you can think of it as data. In the past, when the marketing, for example, like ads and these type of things were used to, you try to see which ads work. I think they try to speed up the data processing to let AI do it. So that's I think the biggest thing is in the sales, customer service, that chat, anything with the banking finance is it, but that's chatbot too with the banking,
right?
But it is still with speaking. I think then there's also with the facial. I mean, obviously now with COVID, being able to recognize face, recognize things, that part. So, and then robotics is a newer thing, but if you think about robot, you think about AI, but it's more for the robot to maneuver, follow tasks, that kind of stuff.
Well, do you think also too, like, I mean, I think people also, they think about robotics and they think about AI, and they're in some ways they're two separate things, but your robot needs a serious amount of AI if it's going to interact with the world or interact with people, not just going, okay, I'm sensing something's over here, I got to stop. If it's really going to interact, it needs a certain sophistication in the AI department.
No, correct. Yeah, exactly. Everything from, if you think about driverless car, right? That's a big robot, but a human. Behind it.
So, we talk about the good stuff associated with artificial intelligence, but what about some potential problems? Do you see any potential problems with incorporating, all of this AI into our lives in these different ways in businesses and, in the way that you see it heading now? Are there any downsides or things that need to be considered at this point?
Yeah, I think the biggest consideration is that you really don't know what's going in. Like, if, for example, if I was building a chatbot that I could program, just say, let's just say make a simple one in Excel. We make Excel. When Brian says this, say this. When, you actually can, then maybe, Brian said the wrong thing and then you want to fix it. You just go in and change it, So with AI, since it's a neural network, and you can't really change, it's hard to change specific things and specific reactions. You can train it more, or you can, change the training data. or you can filter things on the outside. So I think one problem is, you like, for example, with driving this car, sometimes you always hear, making mistakes and things like this, right? Like Tesla thought, this was a truck, but it was actually a sign or something like that. So I think sometimes you can't really check everything. Mm-hmm. So you only run test case and you only have data to improve it. But then how do you know you went too far improvement, or it's too specialized? Or I think that's one of the dangers, is you really don't know what it is, right? It's a black box kind of running itself. So I think, it needs more checks and balances on the outside. Yeah.
Do you think also too, like you'll see, I mean, it's interesting because we talked about like Tesla, right? So you have some edge computing going on. So you have it's being done, some of it, in the car, right? And then you have some of it being done in the cloud. How important, when sort of AI gets to this cusp, is it going to be where it's going to be more self-contained, or is it always going to be dependent on sort of connecting and grabbing new information?
So I think self-contained. Problem is, I think it depends on computer models and the size. As you can get smaller and smaller now, so it could be self-contained. It depends on the task, right? So I think as technology improves and things get smaller, and also they've been able to, before the neural networks are so big, and then they're able to like prune it or make it, there's ways to make it smaller. So that's how edge devices can do the computing, but also so I think it won't need the central server unless it's doing something very complicated.
So before I ask you to tell us a little bit about KidX AI and let us know about when that's releasing, which is soon, I have the famous question. This is like the world-renowned question. Will AI take our jobs?
Yeah, I think some jobs, right? It's already taking, but I think it creates new jobs, I guess, too. So I think it's a balance, but
Okay, I have one more question. Since you are a rocket scientist, when are we getting to Mars? I'm curious. We ask everyone who's worked in the space industry, what year do you predict we're going to get to Mars? People.
I think definitely before 2030, I think. People is longer.
People.
Yeah, I don't know. Because, it's hard because maybe something changes in the economy and people's desires, and maybe it doesn't happen. So I think it's hard. I mean, if it's pushed the way it is now, then maybe less than 15 years. Okay. But we don't know how things will change in terms of people's interest in it. Yeah.
15 years. 15 years. We're gonna look back in this.
We keep track. We keep track of all of our guests. And one day we're gonna give you prizes if you want.
That's right. Right. 15 years. 15 years.
That's if everything's pushed. Like SpaceX keeps pushing, and everybody likes space.
Actually, you're in the pocket. Like most people are saying, 2035. Like that's what most people's sort of prediction is for it, like around that time frame.
I think so, hopefully.
Hopefully. It'd be cool.
Would you guys go? If it's
absolutely.
One-way trip, you would go. No.
One way. I mean, then I'm going to be pretty old, so I'm, I'll be fine.
Brian, you're going to live forever. Who are you kidding?
That's right.
We're going to turn you into AI, Brian.
That's true. And I will go on and on and on. You'll have to deal with me for the rest of your life.
Right. All right. So now, please tell us about KidX AI. I know you mentioned to us before this call that it is, by the time this episode releases, it is going to be launching on Amazon. So tell us about this. Tell us about your work. I know you told us before that you were just working on this for over a year, right? Since before the pandemic. So tell us all about this and the role of AI and AI with children and how you're kind of doing this differently than the last.
Yep. All right. Thanks. Yeah. So KidX. X means interaction. So we were trying to be a voice interaction company, but especially with the young children, a lot of them need the hands-on learning, and so that was a bit idea behind the product and everything, was to help children do the hands-on and also verbal communication. So, my previous company, we launched apps, and one of the biggest issues we noticed was the children, parents didn't like the sense that the children on the screen all the time. Mm-hmm. Also, the swiping and touching, and especially for the young children, they weren't using their hands. So that was the idea behind it. But we realized there's certain things that you need. For example, video interaction is very important. A cartoon's good, and like Peppa Pig and children learning, languages, but I think that humans actually help, especially with the COVID. When you cannot have a teacher in the classroom. So that was the idea behind KidX. We wanted to create a way for children to use AI to self-learn at home, using their hands and using an interactive video person. So so I can kind of show you the product a little bit, but
Sure.
So this is basically the product. Let me see.
Nice.
Yeah. So we use the Montessori rods in the beginning, so children use their hands. So we have a tablet, but actually it's games, but actually we have video teachers in here. So, but it's not live video because obviously you can't do it everywhere. So we recorded teachers, and I would say because this is a 3-year-old to 8-year-old product, the AI is very minimal in the sense that it's because obviously you can't chat with the child too much. But we took a lot of videos, for example, different scenes like small bits, right? And based on the child's interaction, for example, if the teacher says, here's a 3 rod, here's a 1 rod. What do we do when we add them together? So the child says 5, then another video plays saying, no, let's count them together. So we So we create a chat bot through interactive videos based on children interaction. But like I would say, like maybe it's like the chat bot you've dealt with, where it's kind of dumbed down, but it's good for children in that sense. Yeah, so that's the idea behind it. Use hardware and toys and interactive video and chat with it. Hopefully, we can get better and better and go to older audience. Then when we have the video, we can actually do more complicated chatting and more complicated voice. But right now,
can the product understand so is it you said voice interaction? So is the child responding to questions with their voice?
No, so we make it just there's a hardware pad, and when the child it senses the object, so it's sensory.
Oh,
so it's sensory.
Okay,
if you're moving the
because
block,
I was going because I was going to ask, what if you can't understand the child? But okay, even better, you thought of that. You're that's why. That's why you made it.
Exactly. You mentioned that's my previous company. We actually built. So that company got acquired by Silicon Valley robotics company. So first we started making children apps, and they couldn't understand children. Like all those. So we had a lot of children data, and we trained the speech for the children. So that company pivoted from app company to the children ASR company. But you're right about it's hard to understand children because
especially and kids' speech development and linguistics is always at such different places, So so it's very cool that it has the touchpad, and it's they're able to use that to interact because then in some ways it goes beyond language, right? It's just about the math or whatever process they're doing.
Right. Yep. No, exactly. We focus on the math, and I use the Montessori rods, even though it's not specifically Montessori. But we follow Montessori. The rods are really nice. I never did Montessori education, but my aunt is a Montessori trainer, and she was teaching my nieces. And I like how they learn the numbers by actually counting numbers, not like here's 3, memorize 3. So I like that idea. So and it's hands-on. So we put that as but we have logic and brain games, but you use the rods. For example, like we have if I tell you, a memory game, for example, like there's a chicken he hides somewhere. We ask you which door he hide under. Even though it's not math, you still use a rod to place the object.
Right.
But
very cool.
So awesome. So in terms of data and AI, so one part of the AI is the speaking part. The interaction, right? The video. Other part is we can do the assessment. These are actually memory games and things. They're based off the NIH's. There's a NIH cognitive assessment for the 3-8-year-olds. So we based it a lot on that. For example, the red light, green light game, Squid Games.
Yeah.
So there's a go, no go game that NIH made. It's very similar. And like Simon Says, which is actually very good for your child's impulse control. So these type of games, we can use those to assess children at the state of,
How funny is it that we always play red light, green light as a kids, and over a sudden now as adults we're like, what? Oh my gosh, this is Squid Games.
I know. I heard the kids playing red light, green light in the street, and I was like, what are they playing? Why are they playing this?
What's going on? Why do they have the Nerf guns out?
Well, thank you so much, Dhonam. We are going to include a link. You said that this will be live on Amazon, so we'll make sure to include that for all of our listeners, and you can go and grab one for any children 3 to 8 that you know.
Thank you, guys. Yeah, it was a pleasure. Yeah.
Thank you so much for joining us.
Thanks. All right. Bye.